Hello, my name is Manuel, and today Hiroki and I will be explaining linear search. Linear search is an algorithm that requires only a list of values in any particular order to work. In Java, this algorithm is performed by the index of method. Now Hiroki will explain how the algorithm actually works.
Hello, I am Hiroki Sato, and I will be explaining how linear search works. For a setup, you need an array and a key, and key is what you're trying to find inside the array. And for linear search to work, you also have to match the data type of array and key. In this case, it is int. And this is a code for linear search. Now I will be explaining how linear search works. First, you have to traverse through the array, which is shown in this for loop. And this if statement allows you to check each element in the array and see whether it matches with key, which is 123. And if it does not match it, it will skip this return statement and go back to loop. With I being incremented, now I is 1, so now we'll be checking the next element in the array. So let's go through it. So I is 0. So nums of index of 0 is 3, which is not 123, so you go back, and I is now 1. And in an index of 1, you have 5, which is not 123. So now you go to index of 2, and index of 2, you have 6, which is not 123. And in index of 3, you have 2, which is not 123. So you keep continuing this until you find an element that matches with key. In this case, it's 123. So now in this case, we have index of 8. So when I is 8, so number of index of 8 is 123, which matches with 123. So now you can proceed to the return statement, which will return I, which is in this case 8. So this 8 indicates the index of key inside the array. But what if we don't have any key inside the array? In that case, we will return -1, which represents that there is no key inside the array. So runtime complexity shows how fast linear search runs in those three cases. So if key is 1, you only have to try once to find 1 in this array. That's why it's 1. For the worst case, it's n, and n equals to the length of array, because if key is 9, you have traveled through entire array, so you have to try as many times as the length of array in order to find the last number of array. For the average, it's n divided by 2, because on the average, key will be located in the middle of the array. That's why it's 2 divided by n divided by 2. Space complexities shows how much space does this code occupies, and for the linear search is 1, because it does not occupy any extra places as the array number increases, because they don't create extra arrays like in merge or binary search.